In this example, I'm going to go ahead and write an equation of the tangent line to the graph of f of x at the point x equals 1. So in order to write the equation of the line, I'll need two pieces of information. I need a point that it passes through, and then I'll also need the slope. Okay, well I can find the point that it passes through by using the x-coordinate x equals 1 and plugging that into my function. F at 1 will be 1 squared plus 1, so it looks like the square root of 2. So my ordered pair then is 1, the square root of 2. Okay, and that'll give me an x-coordinate and a y-coordinate, so whenever I write my equation in point-slope form, I'm good to go. So the other thing I need is the slope. So in order to find slope, I'll need to go ahead and find the derivative of this function. So f prime at x equals, and so we have the derivative of a function. So over here, we know that the derivative of the square root of u will be u prime over 2 times the square root of u. Okay, so let's go ahead and use that rule. So the derivative of what's inside will be 2x plus 1, and that'll be over 2 times, and then the square root of that function. Okay, so now let's go ahead and plug my 1 in. So 2 times 1 plus 1 over 2 times, and then I have again 1 plus 1. That's a 1 right there. So it looks like it'll be 3 over 2 radical 2. So what I could do is go ahead and rationalize that and get 3 radical 2 over 4, and that will be my slope. Okay, so if I have the slope and I have an ordered pair that the line passes through, I can easily write its equation. And its equation will be y minus the y-coordinate equals the slope times x minus the x-coordinate. Okay, so y minus the square root of 2 equals the slope, which is 3 times the square root of 2 divided by 4, and then times the quantity x minus 1. Okay, so there we have the equation written in point-slope form. And let's go ahead and take a look at the graph as well. Here is our original function, and our value of x was x equals 1, and here's the equation of that tangent line.